Hello guys, my name is IBM and today I'm solving 9702 1 to May June series. These are multiple choice questions. Many of you have asked me to solve the multiple choice questions because you're on pressure. Don't be on pressure. You did your best. So I'm only solving 1 2 because I can't find 1 1. I can't find 1 3. So I'm only solving the question paper which my student did. As soon as I get 1 1, I will solve it. But of course, for now, I'm very busy with marking exams. So it may take almost a full month until marking exams are done. Then I will get back to solving these past paper questions. I'll also record tutorials. For those of you leaving AS to A level, I'll record tutorials for A level topics, topic by topic. I'll record tutorials using the PowerPoints that I use in my class. So this is precisely the question paper which my students did. Managed to scan it, and I just want to go through this. The answers to this question paper may not be 100% correct, but I'm very certain with my experience they could be 98% correct. They may not be 100% correct because I'm not the one who said the question. Sometimes questions are set when the examiner is targeting another response. So, but I'm very certain at least 98% correct. So let's go to the questions. I normally don't want to go through the data. I will not go through the formula. I'll just go straight to question number 1. What is a scalar quantity? So a scalar quantity has only magnitude. A vector quantity has both magnitude and direction. A scalar quantity has only magnitude. It does not have direction. So I think this is obvious. The answer is going to be automatically C. A quantity without a direction, that is a scalar quantity. When you say quantity without magnitude, whether it is a scalar or vector, it has magnitude. When you say quantity that does not require a unit, a scalar quantity can be a physical quantity, and every physical quantity requires a unit. Then if you say a quantity that can be represented as two perpendicular components, that is basically, if we are resolving a scalar quantity into vectors, then that we can do that. So the answer is automatically C. So it's a vector which can be resolved into two perpendicular components, but even a scalar quantity can. The value of quantity x has a percentage uncertainty 2%. The value of quantity y has a percentage uncertainty 4%. The value of quantity w is calculated from the values of x and y. The value of w has a percentage uncertainty of 8%. So what could be the relationship between w, x, and y? So they have told us the value of w has a percentage uncertainty of 8%. If you're a mathematician, you'll notice that 8% is the same as 2 times 2% plus 4%, which means the percentage uncertainty in W is the same as 2 times the percentage uncertainty in X plus the percentage uncertainty in Y. And if you bring in absolute fraction uncertainties, so this will be fraction in W over W times 100. This will be twice fractional in X over X times 100 plus fractional in Y over Y times 100. If I remove the 100, I now notice that the absolute uncertainty in W over W is equal to, so I'll take this power backwards. So this will be X. Okay, let me just remove this. I'm getting back the quantities. So this means W is going to be equal to the 2 was the power of X. So this will be X squared because of addition. So this, by the way, this can be either multiplication or W could be equal to X squared divided by Y. So either this or this. So we check the options which are given. So, oh, by the way, it can be either this, it can be this, or it can be the other way around, or it can be w equals to y divided by x squared. Any of these three options, if any of these three options is there, then it is correct. Because all these ones have the same fractional uncertainties. The uncertainties or percentage uncertainties are added in the same way. So this one is wrong, this is wrong. So this one is telling us it is the y which is squared, which means this is wrong. It is the x which must be squared. So the answer is going to be D. A football is kicked so that it moves vertically upwards through the air. What is the variation in the air resistance and the resultant force acting on the ball as it moves vertically upwards? So let's think about this to be the ball, and I'll put an arrow here to show the direction of motion. The forces acting on this ball are: one, its weight, which is vertically downwards, and two, it's the force due to air resistance. Because motion is upwards, then the force due to air resistance is downwards, which means the resultant force on the object, the resultant force on the object is going to be, because the air resistance and the weight are acting downwards, so it's going to be the weight plus the force due to air resistance. But as it moves upwards, V decreases. V decreases as it moves upwards. As the ball moves, remember at maximum height, velocity is zero, so the velocity is decreasing. So V decreases as it moves upwards. And if V decreases, remember the force due to air resistance is dependent on V. If V decreases, it means the force due to air resistance also decreases. If the force due to air resistance decreases, it means this sum becomes smaller, therefore the resultant force decreases. So the force, which is the resultant, decreases. So one, we know that the resultant force decreases, which excludes B and D. But then what happens to the air resistance? Of course, we know that the velocity decreases as the body moves against gravity. So the velocity, because the resultant force is in the opposite direction to motion, the velocity is decreasing. And since the velocity is decreasing, yet force due to air resistance depends on this velocity, the force due to air resistance also decreases. So it means my answer is going to be A. Which statement is not correct? Which statement is not correct? So one, we have acceleration can be determined from the gradient of a velocity time graph. Of course, if I have graph of velocity against time, I know that the gradient is the acceleration, so this statement is correct. Acceleration is the rate of change of velocity. Change in velocity over time, that is the rate of change of velocity, that statement is correct. Displacement can be determined from the area under the velocity time graph. If I have the velocity time graph, the area is the displacement, this statement is correct. Velocity is the rate of change of distance, so this statement is not correct because distance is a scalar. So velocity is the rate of change of displacement, not distance. Speed, if this was speed, it would be the rate of change of distance. But since it is velocity, it is supposed to be the rate of change of displacement. So this statement is not correct. Question number 5. The diagram shows a laboratory experiment in which a feather falls from rest in a long evacuated, so it is a vacuum, air resistance is not there. So that means the equations of motion can apply since there is no air resistance. So it started from rest, initial velocity is 0. The feather takes a time t to fall from the top to the bottom of the tube. How far does the feather fall from the top of the tube in time of 0.50 t? Of course, I know many people may have just divided this by 2 and got their answer as D. That one I expect. Let's consider the first situation where the feather falls through a distance L. And I will use S equals to UT plus a half AT squared. This part of the equation will be 0 because we started from rest. The displacement S is going to be L for the first case. This will be a half. It is falling due to gravity, so this will be G. Where there is T squared, I'll put capital T squared. This is going to be my first equation. Then let me consider a situation where it has fallen through a distance, let's say a distance x, in a time of 0.50 t. So using the same equation, I will say x equals to initial velocity is still 0. Initial velocity is 0 times t, so this will only be a half times g. Where there is t, I'll put 0.50 t, but this should be squared. So I'm just going to simplify this. This will be x equals to a half times g times 0.5 squared times t squared. So this is going to be my second equation. So I'm going to divide equation 2 divide by equation 1. So x divided by L is going to be equal to a half times g times 0.5 squared times t squared divided by a half g t squared. So a half g has cancelled, t squared has cancelled. So it's like x is going to be 0.5 squared times L, which I am very certain that this should be 0.25 L, which makes the answer to be B. I think it is 0.25 L. Let me check with the calculator. 0.5 squared, that is 0.25. A car travels along a straight horizontal road. The graph shows the variation of the velocity v of the car with the time for 6 seconds of its journey. The brakes of the car are applied from t equals to 1.0 to t equals to 4 seconds. So the brakes are applied between this point here and this point here. I'll divide this into two shapes, maybe for simplicity, a triangle and a rectangle. I think this is 8. The brakes of the car are applied from t equals that to t equals that. How far does the car travel with the brakes while the brakes are applied? So we want it is going to be the area under the graph. We find the area under the graph, the whole graph with the x-axis. So for the rectangle, we have the area is going to be 4 minus 1, which is 3, times on the vertical we have 8. I think that is 24. Then for the triangle, we have the area will be a half times the base is still 3. The height is going to be, I think this is 22. 22 minus 8. So this is going to be 22 minus 8, which is the same as a half times 3 times 22 minus 8. I think that is 16. Yes, I think that is 16. So is it 16? 22 minus 8. I think that is 16. Sorry, it is 14. My math is very bad. Okay, so that is 14. So you have a half times 3 times 14, which is 7 times 4 times 3, which is equal to 21. So the total area is going to be 21 plus 24, which gives us 45. So the answer is going to be B. If you're very good at math, you can use this as a trapezium, and you say the distance is going to be the area of a trapezium, which is a half. So you'll take this side to be A, which will be 22, plus this side to be B, which will be 8, then times the height or the h, which is 4 minus 1, which is 3. So that is 0.5 into 30 times 3. It is still 45 meters. So the answer is 45, I think. The satellites in deep space collide inelastically. That means momentum can be conserved, but remember, for inelastic, kinetic energy is not conserved. What happens to the total kinetic energy and total momentum? Whether the collision is elastic or inelastic, momentum is always conserved. So the total momentum is always conserved. But if the collision is inelastic, it is only kinetic energy. I mean, if the collision is inelastic, it is only momentum which is conserved, not kinetic energy. So we first of all ignore the point where they said kinetic energy is conserved when the collision is inelastic. But remember, momentum is always conserved whether the collision is elastic or inelastic. So it means this one is also going to be not going to be correct. So the momentum is always conserved whether the collision is elastic or inelastic. But if the collision is inelastic, kinetic energy is not conserved. So the answer is going to be C. What is a reasonable estimate of the momentum of a family car traveling at 25 kilometers per hour? So, of course, we know that the mass of a family car should be between 1,000 kilograms to around 2,000 kilograms. If you have a car at home, the mass of a family car is around that value. So we are going to check the momentum to see which momentum gives us mass around those two values. I'll first change the speed to meters per second. So this will be 25 times 1,000 per hour. That is divided by 3,600. 3,600. So the V is going to be 250 divided by 36. That is going to be my value of V. So let me check the first one to see. I'm using the equation for momentum. Momentum is equal to mass times velocity. Let's start with the first one. Remember, I will be making M the subject to check what value of M do I obtain. For the first one, what is M? M is going to be the momentum, which is 1 times 10 to the power of 4 divided by 250 over 36, which is the same as 36 times 1 times 10 to the power of 4 divided by 250. So we're checking with the calculator. 36 times 1 exponent 4 divided by 250. So this is 1440, which means the answer is going to be A, because I can predict, because this has increased by times 10, the mass here is going to be almost 14400 kilograms. You can substitute with your calculator and check. The mass here is going to be 144. I'm going to add 3 zeros, so this will be 123 kilograms. The mass here will be 144. I'll add 4 zeros. 1, 2, 3, 4 kilograms. So it means these are extravagantly big masses. So the answer is going to be 1 times 10 to the power of 4 kilograms, because kilograms per meters cubed, because it's the one which gives us a mass of a reasonable family car. So the answer is A. The ball collides with a wall. Before the collision, the ball moves with a velocity 8 meters per second to the right before the collision. So let me draw here a wall. The ball is moving to the right before the collision with 8 meters per second. And after the collision, it moves to the left. So this is going to be initial velocity. After the collision, it is moving to the left. So the final velocity is going to be 3 meters per second. Remember, velocity is going to be a vector quantity. What is the change in velocity? So the change in velocity is going to be the final velocity minus the initial velocity. That is the change. But we shall say velocities to the right are positive, velocities to the left are negative. So the final velocity is negative 3 minus the initial velocity, which is positive 8. And this gives us negative 11 meters per second. The negative simply means that it is actually the change in velocity is going to be to the left. So the answer is going to be C. A lead pellet is shot vertically upwards into a clay block that is stationary at the moment of impact, but is able to rise freely after impact. Of course, this is a past paper question. If you have watched my topical questions, you must have found this question there. So the mass of the pellet is 5 grams, and the mass of the clay block is 95 grams. The pellet hits the block with an initial velocity of 200 meters per second. It embeds itself in the block and does not emerge. How high above its initial position will the block rise? So we are simply going to use a conservation of momentum. Then we shall use the equations of motion, assuming air resistance is negligible, to find the height. So before collision, let's say after collision, this is what we expect. The pellet is embedded into the block. That means the total mass here is going to be 5 plus 95. So it is now a system whose mass is going to be 100 grams. But before the collision, remember, it's only the pellet which is moving with a velocity of 200. Let's say as soon as they collide, the system starts moving upwards with initial velocity u. Of course, as it goes upwards, u decreases because it's moving against gravity. So momentum is mass times velocity, and I'm using conservation of momentum. Total momentum before the collision should be equal to total momentum after the collision. But before the collision, it is only the pellet which was moving. So total momentum before is going to be 5 times 10 to the power of minus 3, that is the mass of the pellet, times its speed, which is 200, plus the other one was stationary, so I'll just put 0. That's total momentum before the collision. After the collision, it becomes one body, which moves with the speed u upwards. So after the collision, total momentum is going to be the mass, which is 100 times 10 to the power of negative 3, that is the mass, times the velocity with which the system moves, which is u. So I'll cancel out this one. So it means u is going to be equal to 5 times 200 divided by 100. So u is going to be 10 meters per second. So the initial speed with which the whole system moves vertically upwards after the collision is going to be u. So remember, when it reaches the maximum height, v becomes 0. So v at maximum height is going to be 0. So using v squared equals to u squared plus 2as. So 0 squared equals to initial velocity squared, which is 10 squared. Because it's moving against gravity, the acceleration will be equal to negative g. So this will be minus 2 times 9.81, then times the height h. So h is going to be equal to 10 squared divided by 2 times 9.81. So 100 divided by 20, I think the answer is automatically approximately 5 point something. So let's check. 10 squared divided by 2 times 9.81. So the answer is 5.1, which makes it to be A. Two forces act on an object, which diagram represents a couple. First of all, a couple, the forces must be equal in magnitude. Equal in magnitude, which means we eliminate C and we eliminate D. Number two, they must be acting in opposite directions. Opposite directions, which eliminates A. Of course, number three, their lines of action should never meet. Lines of action never meet. The forces will never meet. So this means the answer is automatically B. That was the easiest question. The lines of action of the forces never meet. They are equal, they are opposite. So A is out because they're in the same direction. The diagram shows a uniform rod XY that is freely hinged to a vertical wall at end Y. The rod is at an angle of 60 degrees to the wall. A force F acts at an angle 30 degrees to the rod at end X. The rod has a weight of 3 newtons. Remember, it was a uniform rod, so it means if this distance, if I said the whole of this distance is d, it means the distance from the center to this point is going to be a half d, or d over 2. Okay. The force F is acting at an angle of 30 degrees, so I'm going to resolve F perpendicular to the rod. So for simplicity, if you're a mathematician, I want to resolve F normal to the rod, so that I know that the perpendicular distance will now be the distance d if I take the resolved component of F. And using 30 degrees to resolve F perpendicular to the rod, this will be F sine of 30. So this one is pulling the rod clockwise. Then, of course, 3 Newton is pulling the rod anti-clockwise. I just need the perpendicular distance of this force from the pivot. So I need this distance, which makes 90 degrees. So, I can draw it here. Let me use a different color. I want the perpendicular distance, which is the distance. Of course, it must be making 90 degrees with the line of action of the force. So I want this perpendicular distance. This is opposite. We have the hypotenuse as d over 2. The angle there is 60. So we shall say opposite hypotenuse, that is sine. The sine of 60 is the opposite divided by the hypotenuse, which is d over 2, which means the opposite, which I want as the perpendicular distance, is going to be d over 2 sine of 60. Okay, so now I'm taking moments about the hinge. The clockwise moments should be equal to the anti-clockwise moments. So clockwise, I have F sine of 30 times the perpendicular distance, which is d from the pivot, which should be equal to 3 newtons, which is the force, times the perpendicular distance, which is d over 2 sine of 60. So d has cancelled. Let me change the color. So d has cancelled, and you have 3 divided by 2, that's 1.5. So I have that F is equal to 1.5 sine of 60 divided by sine of 30. So I'll just press my calculator. 1.5 sine of 60 divided by sine of 30. So my answer is 2.598, which is approximately 2.6. So it means this is going to be C. Water has a density. I think this is a past paper question. It has appeared like 3 times. If you check in my topical past paper questions, you will see it there. Water has a density 1 gram per centimeters cubed. Glycerin has a density 1.3 grams per centimeters cubed. A student measures out a volume of 40 centimeters cubed of glycerin into a container. The student adds water to the container to make a mixture of water and glycerin. Assume that the total volume of water and glycerin does not change when the two liquids are mixed. Which volume of water needs to be added to the mixture of density to make a mixture of density 1.1 grams? Okay. So first of all, we need to find the mass of water. We know that the mass of water is the density of water times the volume of water. The density is 1, then the volume is not known, so I'll say 1 times volume of the water. Then the mass of glycerin, of course, is the density of glycerin times the volume of glycerin. So the density is 1.3 and the volume is 40. We also know that the density of a mixture is equal to the total mass. Density of the mixture, let me say total density, is equal to the total mass over total volume, which is actually the mass of water plus the mass of glycerin divided by the volume of water plus the volume of glycerin. So I'm now just going to substitute the total density or density of the mixture is 1.1 equals the mass of the water, which is 1 times VW, which is simply VW, plus the mass of glycerin, which is 1.3 times 40 divide by the volume of water, which is VW, plus the volume of glycerin, which is 40. So we just cross collect like terms. So this will be 1.1 VW. I'm cross multiplying, plus 40 times 1.1 is 44, equals to VW plus, I think 1.3 times 40 is 52. 1.3 times 40, 52. So this is plus 52. Collecting like terms, 1.1 minus 1 will be 0.1 VW. 52 minus 45, I think this would be 8. Then dividing by 0.1, I think VW is equal to 80 centimeters cubed. So the answer is D. This is a past paper question. The force resisting the motion of a car is proportional to the square of the car's speed. I think that one should be known. Force of resistance is always proportional to the square of the speed. The magnitude of the force at the speed of 20 is 800. This is a past paper question too. What useful output power is required from the car's engine to maintain a steady speed of 40 meters per second? So we know that power is equal to force times velocity, but the force is equal to a constant times v squared as given by the relationship. So for the first one, we have 800 newtons equals to a constant times 20 squared. For the second one, we want to find the second force. We have the unknown force equals to a constant times the speed is 40 squared. So I'm dividing the two equations. So F over 800 equals to K times 40 squared over K times 20 squared. So K cancels out. So F is going to be 40 squared over 20 squared times 800. So what does this give us? 40 squared divided by 20 squared times 800. So it's 33,200 newtons. So that is the force. But that's not the answer here. The question wants us to find the output power. So the output power is going to be force times velocity. The force here is 3,200 newtons, then times V, which is 40. I think the answer would be C. Let me press and see. 3200 times 40, 128000 watts, which is the same as 128 kilowatts. So the answer is going to be C. Okay, question number 15. A box of weight W is pulled by force P along the slope. So this force P is overcoming the friction to pull the box upwards, and it is also giving it, it is making it gain gravitational potential energy. Okay, so the friction force is F, length of the slope is D, and the box raises a height H. The purpose of the slope is to raise the box vertically, so it means the useful work output should be equal to mgh. That is the useful work output. It is going to be the gain in gravitational potential energy. It is the useful output, which is the same as the weight times h, because the weight of the box is W. So this is the work output. Then the work input, total work input is going to be equal to the force, which is P, times the distance, which is going to be D. Because P is the one doing the work against F, and also doing work against gravity to raise the box through a vertical height h, it means the work done by the pulling force F is the same as the work done to overcome the friction F, plus the gain in gravitational potential energy, or the work done against gravity. So this is the work input, P times D. This is the work output, So it means the work done against the friction is wasted. So we don't need it in the next part. Which expression gives the efficiency? So the efficiency is going to be equal to the useful work output over the total work input. So the output is W times H, the input is P times D. So this automatically makes the answer to be as simple as D. The kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increase? So we know that kinetic energy EK is equal to a half mv squared. Let this be E1 or just E for simplicity. Then before increasing, this is what we have. After increasing, the second kinetic energy, I will call it E2, is going to be 4 times E. But this is going to be a half. The mass has not changed, but the speed is changing. So I'll call the speed V2, but is squared. So I have to combine these two equations. So 4E is equal to a half mv2 squared. But remember, E is a half mv, so I'll say 4 times a half mv squared should be equal to a half mv2 squared. So a half m has cancelled. Half m has cancelled. So I have that v2 squared is the same as 4v squared. So I take the square root both sides. Root on the left hand side is v2. Root on the right hand side is going to be twice v. So the speed is going to be twice v. So the speed increases by a factor of 2. So the answer is going to be A. A mass of 28 grams is raised vertically upward through a distance of 4.6 meters. What is the change in the gravitational potential energy of the mass? This is a very easy question. So the change in gravitational potential energy is mgh, or mg times change in height h. So this is direct. The mass is 28, you just change it to kilograms, 10 to the power of minus 3. G is 9.81. Then the change in height is 4.6. So 28 exponent minus 3 times 9.81 times 4.6. So this is 1.26, or it is approximately 1.3 joules. So the answer is B. A sample of metal is subjected to a force which increases to a maximum value and then decreases back to 0. A force extension graph for the sample is shown. When the sample contracts, it goes back. It follows the same force extension curve as when it was being stretched. But they say if it follows the same, it means it's going to go back like this. Then now here it will be a straight line going back to 0. It is following the same curve when it is unstretched. What is the behavior of the metal between X and Y? So if it follows the same path when it is unstretched, then we cannot say that X and Y was only plastic, that there was plastic deformation between X and Y, because if there was plastic deformation, some energy would not be returned. Perhaps if X is the proportionality limit, then Y is just the elastic limit. But remember, plastic deformation starts after the elastic limit. So Y is the elastic limit, and after Y, that's when we shall have plastic deformation. So it means we have not reached plastic. This is proportionality limit. This is elastic limit. We have not yet reached plastic, because if there was plastic, on removing the force, it would not follow the same path. Some extension would remain. Perhaps it would come up to here. The graph would come and it comes up to here to show that some extension remained when the deforming force is removed. So we don't expect plastic deformation here. This is also a past paper question. So both elastic and plastic deformation, no. Not elastic and not plastic. Of course, there is elastic deformation. So this is not correct. Elastic but not plastic. So the answer is going to be C. Plastic but not elastic. That is not true. We cannot have plastic before elastic. Two wires P and Q made of the same material are stretched with an increasing force. A graph is plotted of the variation with the force of the extension of each wire. The wires have the same original length, so let me just call it L, but different diameters. I'll call it D. I'll call diameter D. What is the ratio of the diameter? So I'll say diameter for Q will be D because they have different diameters. So let this be DQ. Diameter for P, let it be DP. They have the same original length. So we know that Young modulus equals to the force of area times original length over extension, or divide by force over area divided by extension of original length. So it means when I make, because it's a graph of extension against force, I'm going to make E the subject. So small e the subject will be F times L over A times E, capital E. Remember, A is the area, and we know that the area is pi d squared over 4 since we have diameter. So E is going to be F. The 4 will go up, so it becomes 4L divided by pi d squared times E. So it is a graph of E against F, which means the gradient, if I compare this with y equals to mx plus c, it means the gradient is this. So the gradient is equal to 4L over pi. Pi times E is going to be constant because they are from the same material, so that means E is the same. So this is 4L over pi d squared times E. Because the length is the same, 4 is the same for both wires, pi and E are going to be the same. I'll simply say the gradient is going to be a constant divided by d squared because it's only the diameter which is going to be changing. Okay, now I can have two equations. So the gradient for Q, let's find the gradient for Q. For Q, we have the gradient is going to be 1 minus 0 divided by 2 minus 0 is equal to K over diameter for Q squared, which means the constant K is going to be diameter of Q squared divided by 2. Let's check the gradient for P. For P, it is 3 minus 0, which is 3, divided by 2 minus 0, which is 2. This is going to be equal to a constant divided by the diameter of P, which is diameter of P squared. So remember, we know what K is. So I have that 3 times diameter of P squared divided by 2 is also equal to K. The two equations are equal. You can do this in the simplest way, but me, I love doing some mathematics. So I'm combining these two equations. So I'll say diameter of Q squared divided by 2 is the same as 3 times diameter of P squared divided by 2. The 2 has cancelled. So I have diameter of Q squared divided by diameter of P squared is equal to 3. I find the square root both sides. So it means that diameter of Q divided by diameter of P is the same as the root of 3, which makes the answer to be C. I don't think that is also a repeated equation. It's a past paper question. An extension force graph for a spring is shown. What is the spring constant? I think this was just a giveaway. By Hooke's law, F is equal to K times X, which means K is equal to F over X. F is 6.0 and X is, the answers are in newtons per meter, so I'll say 15 times 10 to the power of minus 2. 15, I think 6 divided by 15, that is approximately 40. It is 0.46 divided by 15 exponent minus 2. I think that is 40. So the answer is D. A man stands stationary in front of a swing. A child sits and swings. The child blows a whistle that emits a sound at a constant frequency. The man observes the frequency of sound when the swing is at positions X, Y, and Z. So it's like it moves, the child moves in this pattern. So that means these are the highest points. X and Y are the highest points. Remember, at maximum, at the highest point here, V goes to 0. The speed of the child goes to 0. Here, the speed of the child also goes to 0. Vs goes to 0 there. And we know that when the child is passing point Y, let's say moving in this direction, the speed is maximum. Vs is maximum at that position. So when will the man hear the highest frequency? I think the man will hear the highest frequency when the child is passing Y, but towards him. Because if we look at the equations, the observed frequency is equal to V divided by V plus or minus the speed of the source, then times the frequency of the source. So at X and Z, speed of the source equals to 0. At X and Z, speed of the source equals to 0. What does that mean? F naught is going to be V over V times Fs, which means F naught is the same as Fs. The man will observe the normal frequency of the sound. But at Y, speed, Vs, speed of the source is maximum. But remember, for high frequency, when the child is moving towards the observer, it is minus. When the child is moving away from the observer, it is plus. So in this direction, F naught is greater than Fs. If he's moving away, F naught will be less than Fs. So the question is, when will the man hear the highest frequency? So he must be moving towards. But when the speed is maximum, and the speed is maximum when it's just passing equilibrium. So the answer to this question, which most of you failed, certainly, I think it is going to be C, when the swing is at Y and moving towards the man. I know most of you said X. The examiner cannot be such a fool. A loudspeaker is playing music in a room. The door to the room is open and has a width of 0.8 meters. Sound waves of many different frequencies pass through the doorway and diffract. The speed of sound in air is 340. Which frequency of sound wave diffracts the most as it appears through the doorway? So, of course, we know that the wavelength should be approximately the same as the size of the gap for diffraction to be maximum. So we have to check these frequencies to see which one gives us a wavelength very close to 0.8. So from wavelength equals to V over frequency. So I will check this one first. Wavelength here equals to V is 340. What is the frequency? 340 divided by the frequency, which is 2.4, exponent minus 3. So this is very big. I've not checked this one, so this is wrong. Let's check the second one. 340 divided by 8 exponent negative 1. This is 45. It is also very far from 0.8. So this one should be approximately 0.8 meters. The size of the gap should be, the wavelength should be approximately 0.8 meters. So that one is also wrong. Let's check the third one. 340 divided by 2.7 exponent 2. So this is also 1.25. I think it's also far from the answer. Let's check the next one. 340 divided by 4.3 exponent 2. So this is 0.79. So here the wavelength is 0.79, which is approximately 0.8. So diffraction will be maximum for this frequency here. A stationary sound is set up between a loudspeaker and a wall. A microphone is connected to a cathode ray oscilloscope and is moved along a line directed between the loudspeaker and the wall. The amplitude of the trace on the CRO rises to a maximum position at point X, falls to a minimum, and then rises once again to a maximum. So this is what we are having, something like this. It raises to a maximum at X, it falls to a minimum, and then rises again to a maximum at point Y. So we have an antinode here, a node, and an antinode. Remember, the distance between an antinode and another antinode is always half wavelength. Okay. The distance between X and Y is 33 centimeters, so we can now find the wavelength. So 33 is equal to a half of wavelength, which means the wavelength is going to be 66 centimeters. The diagram could represent the CRO trace of the sound received at X. Okay, so sorry, which diagram could represent the CRO trace of the sound received at X? So let's first find the frequency. Since we have the speed, frequency is going to be V over lambda, which will be 330 divided by 66 times 10 to the power of negative 2. I think this is 500 because the other one is half. 330 divided by 66 exponent minus 2. So the frequency is 500 hertz. So which of these graphs is going to give us a frequency, or what is the period? If you want, you can find the period. So the period is going to be 1 over f, which is 1 over 500. I think this is 2 milliseconds. But remember, period is the length representing one cycle times the time-based setting. So the product of L times the time-based setting should give us 2 milliseconds. So let's check. Here, what is the period here? L is 1, 2, 3, 4, 5, 6, 7, 8. So here we have 8 centimeters times 0.5. I think this is 4 milliseconds. So this is out. Let's check C. 1, 2, 3, 4, 5, 6. So here we have period is going to be 6 times 0.5. I think this gives us 3 milliseconds. We can check D because I know D should also be wrong, I think. 1, 2. So the period is going to be 2 boxes times 0.5, which is going to be 1 millisecond. So D is wrong. So the answer is going to be B. Let's check B. The period is going to be length representing one cycle, 1, 2, 3, 4. That is 4 centimeters times the time-based setting, which is 0.5 milliseconds per centimeter, which gives us 2 milliseconds. So the answer is going to be B. Polarization is associated with a certain type, certain waves. Polarization is only for transverse. It's only for transverse waves. Radio waves are which waves cannot be polarized? Radio waves are transverse, they are electromagnetic waves, they undergo polarization. So the answer here is going to be B because sound waves are longitudinal. These ones are longitudinal, they do not undergo polarization. UV light is electromagnetic, which is transverse. X-rays is electromagnetic, which is transverse. So the answer is only B. They cannot undergo polarization. A guitar string is plucked. A guitar string is plucked. Which statement describes the resulting wave? When we pluck a guitar string, if this is the string, when we pluck it, it will move like this. So it vibrates like that. So that means the string vibrates like that. But when we hear the sound is longitudinal. So it's like the vibrations are transverse, but then they are causing longitudinal waves. The vibrations are transverse, but they are causing the surrounding air molecules to produce sound, which sound is longitudinal. So which statement describes the resulting waves? Longitudinal waves on the string cause longitudinal waves in air. The waves on the string are transverse because the string vibrates perpendicular to the direction of propagation of the energy of the wave. So these two are wrong. The transverse waves on the string cause longitudinal waves in the air. So on the string, we have transverse because the string vibrates perpendicular to the direction of the wave on the string. But then, because we hear the sound, it means the transverse waves on the string are causing longitudinal waves in the air. So the answer is going to be C. A diffraction grating with n lines per meter is used to diffract light of various wavelengths. The graph shows the relation between the diffraction angle theta and lambda for different wavelengths in the nth order interference pattern. Remember, for diffraction grating, n lambda is equal to d sine of theta. Remember, d is 1 over the number of lines per meter, so we shall simply say that n times lambda is equal to d, which is 1 over the number of lines, sine of theta. Making theta the subject because they have plotted sine theta against lambda, so I'll say sine theta equals to n times capital N times wavelength. So compare this with y equals to mx plus c. It goes through 0, so there is no y-intercept. On the y-axis I have sine theta. On the x-axis I have lambda. It means the gradient should be n times capital N. So this makes the answer to be automatically A. A stationary sound wave is formed in the air column inside a tube that is open at both ends. It is open at both ends. So the tube is open at both ends. The stationary wave has 3 nodes. So of course we expect an antnode here and an antnode here. So we have 3 nodes. So let's say 1, 2, 3. So if you were to sketch this, so you have 1, 2, 3, 4 antinodes. So the answer here is automatically 4. Normally, if it is an open pipe, for open pipe, the number of antinodes equals to the number of nodes plus 1. For a closed pipe, the number of antinodes is the same as the number of nodes. For a closed pipe, number of antinodes is the same as number of nodes. For an open pipe, the number of antinodes is always 1 more than the number of nodes. So since we have 3 nodes, we expect the number of antinodes to be 4. 1 more. A node, a node, and a node. There are 3 nodes. We are seeing 4 antinodes. Interference fringes of separation x are observed on a screen at a distance of 1 meter. At a distance of 1 meter from the double slit that is illuminated by yellow light of wavelength 400. So this is a double slit. We know that for a double slit, wavelength equals to AX divided by D. So for the first one, of course, D is 1 meter. We have yellow. So I'll start with the yellow. So 600 nanometers equals to A. X is the fringe separation. So I'll say A times X divided by 1. So it means AX is 600 nanometers. At which distance from the double slit would interference fringes of the same separation X be observed when using blue light of that wavelength? So we now have 400 nanometers and A has not changed, but they want us to find out which distance from the double slit would the interference fringes of the same separation x. So x is remaining the same. The fringe separation is still x, but d has changed. So I just combine these two equations. Where there is ax, I'm just going to put there 600. So I'll say 400 nanometers is equal to 600 nanometers divided by d. So d is automatically going to be, this is going to be nanometers as cancelled. Of course, I remain with the meter. Remember, this was meter. So when I cross multiplied, this is 600 nanometers times 1 meter. So this is going to be 600 divided by 400. What is 6 divided by 4? Is it 1.5? Yeah, 1.5. So the answer is going to be D, 1.5 meters. What is the definition of potential difference across a component? We know that V is equal to W over Q. The energy converted from electrical to thermal or to other forms per unit charge. So that is energy transferred per unit charge. So this was automatically, the answer is automatically A without wasting time. Energy transferred per unit charge. Energy transferred per unit current, E over I, that is not V. Energy transferred per distance, that is not E. Energy transferred over time, that is not V. The diagram shows a cell of negligible internal resistance C connected to a switch and two resistors of resistances R and 2R. The circuit also contains two ammeters, X and Y. The reading on X is 4. So the reading here is 4 amperes when the switch is open. Okay, so I can use that to find the EMF of the cell. So the EMF is going, if the reading of the ammeter, if the switch is open, the PD here, V, is the same as the EMF of the cell. So the EMF is going to be the same as V, which will be, I'm using V equals to IR. The PD across this is V, which is going to be current, which is 4 times resistance R. So it means the EMF is 4R, which remains constant. That is equation number 1. What are the readings on X and Y after the switch is closed? So when the switch is closed, what happens to the current? Of course, the current total resistance has increased. The EMF, remember, it remains constant. The EMF is going to be equal to the current times total resistance. So this is going to be the current I, which is not known. Let's call it IX, which is total current, times total resistance. These are in parallel. So the total resistance is R times 2R divided by R plus 2R, which is 2R squared over 3R, which gives us 2R over 3. That's total resistance. So this is the EMF. So it means the EMF is going to be equal to this. But remember, the EMF is a constant. So I'll simply say 4R is equal to Ix into 2R over 3. This was the second equation, remember. I'm combining the two equations. So it means Ix is equal to R as cancelled. Ix is going to be equal to 4 times 3 divided by 2, which is going to be 6 amperes. So total current is 6 amperes, and the current is divided in the ratio of, the current coming here is 6. So let's say this is I1 and this is I2. But remember that, okay, I'll do this mathematically. There's no problem with that. But of course, you notice that the current which goes through R is going to be I1 is going to be twice I2 because current is inversely proportional to resistance. So I1 is the same as twice I2. So if I say this is I1, this is going to be twice. I mean, if I say this is I2, the other one is going to be twice I2. So I'll say 2I2 plus I2 is equal to 6. by Kirchhoff's first law. Or you can say 6 equals to I1 plus I2. But remember, I1 is twice I2. So in other words, I'm saying 3I2 is equal to 6, which means I2 is going to be 2 amperes. And if I2 is 2 amperes, automatically I1 is going to be 6 minus 2, which is going to be 4 amperes. So the question is, what is the reading on X and what is the reading on Y? So on X, it should be 6. So A and B are out. But on Y it should be I2, which I2 is going to be 2 amperes. So the answer is going to be C. I2 is the current on Y. So that is 2 amperes. The IV characteristic for 4 components, A, B, C, and D are shown. Which component has the greatest resistance when the PD across it is V1? So because these are different lines, A and B, these ones have a constant PDs, constant resistance because they are straight lines. So I know that, or we know that if I use V is equal to I times R, making I the subject, I is equal to V over R, which means the gradient is going to be 1 over R. Or I can say R is equal to 1 over the gradient. So the line with the greatest gradient, or you can even compare the values of I with the values of R. But if I look at this, okay, maybe I can take V1 for this one, compare with this, just compare these ones, these two, compare this if you want. So let's see. I'm going to call this one ID. I'll call this one IC, IB, and I'll call this one IA. So let me even ignore the gradient and I just use the expression for resistance, R as being equal to V1 over I. So here it will be V1 over ID, here it will be V1 over IC, here it will be V1 over IB, and here it will be V1 over IA. So we want to find the one with the greatest resistance when the potential difference across it is V1. So we want the one with the greatest resistance. So note that I1, IB, and IC, these are big values. Now we have to choose between C and D. We have to choose between C and D because, of course, very first you will think that IC, the current corresponding to V1 for C is greater than the current corresponding with V1 for D. So it means the answer here is automatically going to be, I think the answer is going to be D. No, I don't think it is D. I think the answer is going to be C, because at V1, when I look at the gradients, the gradient for this, because this is a decreasing gradient, means at V1, it's like here the resistance is now increasing because the gradient is decreasing, and here the gradient is increasing. Which component has the greatest resistance when the PD, when the potential difference across it is V1? The gradient here is higher than the gradient here. And when the gradient is higher, if this is higher, the resistance is going to be lower. When the gradient is lower, if I draw a tangent here, the gradient is going to be lower. A smaller gradient, is going to give us a higher resistance. So the answer is going to be C, in my knowledge. If you have a different opinion, you can always raise it, but I believe the answer is C. When I try to draw a tangent here, I see as if the gradient of this line is smaller than the gradient of this one. And if the gradient is smaller, then the resistance is going to be greater. So I think the answer is going to be C after V1. But before V1, the resistance D had a higher resistance. Okay, that question is open for discussion, but I think it is C. A cylindrical wire has cross-sectional area A and a number density of free electrons capital N. The wire has current I and free electrons have average drift speed V. The second cylindrical wire has cross-section area 0.1. So for the first one, I will just simply say I equals to never, which is N E V times A, where E is the charge of each electron. Then a second wire has cross-sectional area 0.5 A and the number density twice N. In this wire, the free electrons have average drift speed 2V. So this one I will call it I2. The current through them I will call it I2. N is going to be twice N. Of course, the charge of the electrons is the same. The drift speed is twice V. And the area is 0.5 A. So it means I2 is going to be 4 times 0.2, which becomes 2 N E times V. So then times A. So this means I2 is going to be twice I. So the answer is automatically going to be C. An electric current is formed by moving charge carriers. What is not a possible charge on the charge carrier? So here I think the answer is automatically going to be B, because we know that the charge should be equal to N times E, where N should be equal to plus or minus 0, 1, 2, and so on and so forth. So we are just going to check for N. N should be Q over E. Here, 4.2 divide, remember E is 1.6 times 10 to the power of negative 19. So here, 4.8 divided by 1.6, here N is equal to 3. And here N is equal to 1. I think here N equals to 3.2 divided by 1.6 is 2. But this one, 2.4 divided by 1.6 is 1.5. It's not a whole number, so this one is not a possible charge. Charge is a multiple of the element, is a whole number times the elementary charge. Which description of Kirchhoff's first law is correct? Remember, Kirchhoff's law is sum of currents into a junction equals sum of currents out of the junction, and this is a conservation of charge. So it means the answer is automatically A. It considers the currents at a junction in a circuit and is a consequence of conservation of charge. I don't need to check the rest. Two resistors or resistances R and R are connected in parallel. The value of R is less than that of capital R. Which statement about the combined resistance of the two resistors is correct? So of course, combined resistance of the two resistors, because they're in parallel, is going to be R times capital R over R plus R. Sum, product over sum, that's total resistance for these ones. So it is equal to R plus R. This is no wrong. It is between R and capital R. Of course, whenever we have resistors in parallel, total resistance is less than the resistance of just one resistor. Let's say this was 2 and this was 3. So what is total resistance? Substituting this to be 2 times 3 over 2 plus 3, which will be equal to 6 over 5. I think this is 1.2, which is less than 2 and is less than 3. So it is both less than, it's less than 2 and less than 3. So this statement is not correct. It can't be greater than R plus R. It can't be greater than 5. That is wrong. So the answer is D. It is going to be less than 1.2. The diagram shows 4 identical resistors connected in a circuit. Which resistor dissipates the most power? Which resistor dissipates the most power? So the easiest way to do this is just to give them voltages, resistances, because they're identical. Let me just say the power supply is 10. I'll use 10 volts. Let me use 10, or maybe I should use a simpler number to divide with, such as 6 volts. And I'm going to give each of them 1 ohm. So let me first of all find the total current or total resistance. R total will be, this will be 2 times 1 over 2 plus 1, then plus 1, which will be 2 over 3 plus 1. 2 divided by 3 plus 1. So this is 5 over 3. So that is total resistance. Then if I want to find the current in A, the current in A is going to be equal to V, or is going to be equal to the current in A is automatically going to be the EMF over total resistance, because it is in series with the battery. So it will be 6 divided by 5 over 3, which is going to be 6 times 3 over 5, which is 18 over 5. So the current here is 18 divided by 5, 3.6. So all this can't go through this. Remember, they are identical. And the power is equal to I squared times R. They have the same R, but all the current of 3.6 is going through A. So it means the power in A is going to be the greatest. So I think the answer is automatically going to be A. Why can't it be B, C, or D? Because when the 3.6 reaches here, it divides. So the current going through here is current here is less than 3.6. The current here is also less than 3.6. And remember, power dissipated is I squared times R. So it means the power in the rest is going to be less compared to the power in A. So the answer is automatically A. Nuclide X with the proton number Z undergoes beta decay to form nuclide Y. So since this is accompanied by beta plus, W is supposed to be, this is a positron. A positron is normally accompanied by an electron neutrino. A positron is normally accompanied by an electron neutrino. So what is the equation here? So a proton, which is represented like that, is becoming a neutron, which is represented like that, plus Y plus beta. Sorry, it is becoming a neutron. I don't need, Y is going to be a neutron. Of course, Y is going to be a neutron plus an electron neutrino. So this is a beta plus, which is 0, 1. So the equation, I think it is balanced. So what is the proton number of Y? So Y is going to be having, so what is the proton number of Y, and which particle is represented by the symbol W? So Y is going to be, the proton number of Y is 1 minus 1, or it is Z because the proton number of X was Z. This was Z. So the protons, a proton changes into a neutron. So we have lost one proton. So the proton number is Z minus 1. And the particle W is automatically a neutrino. So this one is wrong for antineutrino. But we only have a beta plus when a proton becomes a neutron. So I can add here Y if I want. So the answer is automatically going to be B. Proton number reduces by 1. And this is accompanied by a neutrino. Which fundamental particles form a hadron? Hadrons are of two types. We have a meson and we have a baryon. What makes these ones hadrons? Because they are made up of quarks. Of course, a meson is made up of a quark plus an antiquark, and a baryon is made up of 3 quarks. So which fundamental particles? Of course, these are automatically quarks. The unstable nuclide X21884 decays through the sequence of emission of alpha and beta minus particles to form a stable nuclide. Why? So X, which is 21884, is giving us Y, which is 21083 plus alpha plus beta. This was, I think, Feb March paper, Feb March question. So this is beta minus, which is 0, -1. So let's say it gives us, I'm going to change the color for this. Let me use red. So let's say it gives us A, alpha particles, and B, beta particles. So we are just going to balance this equation. Considering a nucleon number, we have that 218 is going to be 210 plus, remember alpha is 42, 4 alpha, then plus B times 0, which is 0. Sorry, 4 times A. Alpha is 4, 4 times A. So what is A here? So A is going to be 218 minus 210, which is 8 divided by 4, that is 2. Then B, we balance the proton number, 84 on the left should be equal to 83 plus A times 2, which is 2A, minus B times 1, which is B. So 84 minus 83, I think that is 1 equals to 2 times 2 minus B, which gives us 1 minus 4 minus 1 equals to 4 minus B, which is -3, which is 3. When I take this the other side, I have -3 is equal to -B, so B is equal to 3. So the answer is going to be C. And lastly, which statement about radioactive decay is correct? Radioactive decay is correct. Neutrinos always emitted during alpha decay. That is not true. Neutrinos are emitted during beta decay. Neutrinos and antineutrinos are emitted during beta decay. Alpha particles are emitted from a radioactive sample having a continuous range of kinetic energies. This is only true for beta particles, not alpha particles. Beta particles are emitted from a radioactive sample having a continuous range of kinetic energies. So the answer is going to be C. Beta particles are emitted with a continuous range of energies because they are accompanied by particles such as the neutrinos and antineutrinos.
Hello guys, a big thank you for supporting my channel. You have made me very popular and I'm grateful. Thanks to the students all over the world, especially Pakistan, India, Bangladesh, Rwanda, Zambia to mention but a few. You have been the greatest fans in my teaching career. Thank you for always watching my videos, giving suggestions on, asking questions, making constructive criticism and corrections. I love you so much and wish you success in your academics. Continue sharing the channel with anyone involved with Cambridge Physics. If you are new to my channel, please consider to subscribe and share and like the videos. Hit that like button and bell icon to keep updated. Thank you so much.